So 8.1.4, can it still be factored? Factoring completely. That's what we're talking about in this thing. All right, so factoring completely. There are several ways to write the number 12 as a product of factors. 12 can be rewritten as 3 times 4 or 2 times 6 or 1 times 12. It can also be written as 2 times 2 times 3. While all of these products is accurate, only 2 times 2 times 3 is considered to be factored completely since the factors are prime and cannot be broken down anymore. So, during this lesson, we'll talk and learn more about what it means for a quadratic expression to be factored completely, which means broken down as much as possible. As much as possible. So what we're talking about with that 12 is if we take 12 and we can break it apart as 4 times 3, and then the 3 is just 1 times 3, so we can leave that 3 there, so that one's done. But the 4 can still be done as 2 times 2, and then those two are done. That's 2 times 2 times 3. Now, even if we start off with the 6 times 2, okay, the 2 is done, but the 6 can still be 3 times 2, so now it's done with the 3 times 2. Redo that again. 12, 6 times 2. The 2 is done. The 6 can be gone as 3 and 2. So now that's completely factored, and it's still 2 times 2 times 3. So after you break it down completely as much as possible, you can't take it any further, and you're done. So that's why the factors of 12 completely factored is 2 times 2 times 3. So that's completely factored. It cannot be broken down anymore. So that's what we're talking about. Okay, so we're going to factor these, and we're just going to kind of just practice a little bit of factoring here. So we've got our rectangle, okay, and then we've got our diamond per se, okay, for this first one, and we know that we're going to have 2 of these right here, okay, and if we take the first 2, these 2 are going to go right here when we multiply them, and they're going to end up going this way. All right, so let's do that. So that's 9x squared, and then this is 4, and 9 times 4, that's 36x squared. Okay, and then you take that middle term, which is right here, and that's what's going to go right in this space. Let me redo some of this here. And then we've got to figure out what adds to negative 12 that also multiplies to 36. And so we've got 12 and 3, we got 9 and 4, we got 36 and 1. 12 and 3, doesn't quite get us to negative 12. 6 times 6, yes. So we could have negative 6x and negative 6x. That works. Negative 6 plus negative 6 is negative 12. Negative 6 times negative 6 is positive 36. So now all we then have to do is we can look at this and go, hey, the 9 squared and the 4, those are perfect squares. So we could say 3x and 3x, that's what gets us there. And then 2 times 2 is 4. Okay, and then we have to have a negative. So that's what we end up with, which is another perfect square, which is 3x minus 2 squared is actually equal to 9x squared minus 12x plus 4. So that's interesting. That's another perfect square. Okay, so that's that one. And there we go. Happity hoppity hoopity hoop. Factored completely. Okay, now we have this one. We have two squares and it's a difference, and we don't have any middle term. So isn't that kind of nice? So if we look at this, I will predict. Let's see. Well, let's just go through it. Okay, so we're going to take this. That's going to go here. Then we're going to take the middle term, and that's going to go here. And that is, there's no middle term. All right, so that's just going to be 0x, and then we've got 81m squared. It's not x again. Fine. That's just going to be 0m. And then 81, and then a negative 1, which is a negative 81m squared. And so what's going to do that is 9 and negative 9. 9m and negative 9m, because 9 minus 9 equals 0, and 9 times negative 9 is negative 81. So the sooner that we start actually recognizing some of these patterns, the easier the math is going to get for us. And then, so we have 9m and negative 9m. So we have negative 9m and 9m for no apparent reason. Okay, and then we know that this is going to have to be 9m and 9m. And in order to get a negative 9m, we need a negative 1. And in order to get a positive 9m, we need a positive 1. And 1 times negative 1 is negative 1. So what we end up with is 9m plus 1 times 9m minus 1 is equal to 81m squared minus 1, which is the difference of squares, because of that subtraction in the solution. So we got a perfect square and the difference of squares. Okay, so now we got this here, so I'm going to rewrite this as x squared minus 11x plus 28, just because I like to. And then I'll put this over here, and then I'll move it over later. Okay, and we know that we have our leading term, our two leading terms are here and here. And when we put them, they're going to go like this and multiply, and we're going to get something that goes here. And then we have our middle term here, which is going to end up going right there. All right, so we have x squared plus 28, which is going to leave us with 28x squared, and then we have a negative 11x here. And negative times a negative is a positive, so both of these have to be negatives because we're adding them together. And that would just be 7m and negative 4m. And then looking for our factors, we would say, okay, we need the x, and we also need the x to get the x squared. To get a minus 7, we need a negative 7, and to get a negative 4, and then that gets to a positive 28, negative 4 times negative 7. So that takes care of that. So we'll just move this over to there. Okay, and that leaves us then with and that's factored. Okay. So now we come back up here and we do it all again. Okay, and so we know that what goes in here is going to go right here. And then the thing that's going to go there is right here. Okay, and the two leading ones, these two, are in the green. So we have 3 and we got 3n squared. We got 3n squared positive 6. 6 times 3 is 18n squared. And then we got 9n. And so 9 times 2 is 18. 6 times 3 is 18. Okay, so we got 6n and 3n. 6 plus 3 is 9n. 6 times 3 is 18n squared. Cool, so we got 6n and 3n for no apparent reason. And put them in here as we like. Okay, so we know we need an n and an n. And we got 3's going across, so we need a 3n. And to get that 3 over there, we need a 1 that's positive. And then to get the 6, that would need to be a 6. So, and 6 times 1 is 6 if it's positive. So this is what we have for factoring this one. Is we have 3n plus 6 times n plus 1. And we've learned that in the last lesson we could actually take a 3 out of this. So let's take that one step further. And we can then go 3. And so that would be 2n plus 2. No, that would be 1n plus 2 because 3 times 1. So that's an n plus 2 times that n plus 1. And there we go, and now we are completely factored. And that's what we're going to be talking about today. So we're going to be talking about completely factoring things out because we know that 3 can go into 3 and 3 can go into 6. That's 3 times 1, that's 3 times 2. So we can undistribute to get there. And that's what we're looking at today, and that will avoid multiple answers. Okay, so that's kind of what we're going to do with this. And so the first step in determining other factors for this is really we're just going to completely factor this right now. And so let's first take out the 3. So let's undo a 3. So let's take out a 3. So this is 3 times 1, this is 3 times 3, and this is 3 times 2. So if we take out a 3, what we're left with is just that madness. What's left in there? So we have an n squared plus 3n plus 2. And now it's a lot simpler to deal with. So then if we take this over here, and we do our magic on the n squared plus 3n plus 2 part, the part that's in the parentheses, okay, what we end up with is we'll end up with something that looks a little bit like this. Okay, and so we know, same thing, different day, just on a different week or month. Okay, so we're still doing the same sort of thing, same practice or procedure or logical thinking or methods will work with similar problems. So we know that we've got our first leading term, which is here, right there. So that's the beginning and the end. N squared and 2, which is 2n squared. And then you've got this 3. Which very simply put just goes right here as a 3n, and we know that 2n times 1n, 2 plus 1 is 3, 2 times 1 is 2, and 1n. So I'm going to put an n here and an n here to give us the n squared, and then that means we need a positive 2 to get this, and we need a positive 1 here, and so now that is what is actually in here. So that's what we end up with. So n squared plus 3n plus 2 becomes n plus 2 times n plus 1. And so what we really have then for completely factored form, so we took this and we did that to it. So what we really so what we end up with is we just end up with this. 3 times n plus 2 times n plus 1. And that is the complete factoring of 3n squared plus 9n plus 6. So this is factored completely. And so that's just kind of how we do it. That's where we want to get to with these, is to factor them all completely. And we do that by taking things apart, either in the beginning or we take them apart in the end. It's oftentimes easier to take them apart in the beginning. So, without factoring these, we're going to predict which ones have more than one factored form. And so we do that with the same process. 2, 10, and 12, those are all even numbers. This is 2 times 6, this is 2 times 5, and this is 2 times 1, which means we could pull out the 2 on each of these. So let me do this. Instead of having this be slashed out, let me circle that here like this, so we can pull out the 3, and there it is. So then we have 1 times the n squared, 3 times the n, 2 times, and then 2 times 3, which makes 6, so that's just 2, which is left. So that's what we did here. So this one will have more than one form. Okay, now if we look at the next one here, that 10, well, that's 5 times 2. This 25 is 5 times the 5, and this 15 is 5 times 3, and we can see that we can pull out a 5. So this one will also have more than one. And then if we look at this 5, well, that's 5 times 1. 23 is 23 times 1, and that 10, well, already the 5 and the 1, we're not going to pull out a 1 because that's kind of crazy. So this one is simplest. So this one may not have more than one factored form. So this one is a no. And then 3, 7, and 6, 3 times 1, 7 times 1, and so this one's a no also. So when you cannot pull something out, you just go right ahead. If you can pull something out, pull it out and then factor it. So this is what we're talking about with factoring. Okay, just like we did with the 12, we got 60. So simply put, this is 6 times 10. And you can still take each of these down. That's 2 times 3, and that's 5 times 2. And we can't take these any further, so we would say that, hey, that's done. Okay, so 2, 3, 5, 2, that is now completely factored. Okay, so let's start off with something else. Let's go with 5 times 12. Well, the 5 is done, because 5 is prime, and then 12, that can be 6 times 2, and now the 2 is done, and this is just 3 and 2 for that one. And so we get 5, 3, 2, and 2, which is the same numbers that we had at the end of our tree for the first one. And then for the 60, let's go with, let's see, 6 times 10, 5 times 12, 15 times 4. Just as another one, 15 times 4. Well, 4 can be broken down into 2 times 2, and 15 can be broken down into 5 times 3. And now we're back down to the same bottom numbers each time. So that's what we mean by completely factoring. You can't take it apart anymore. So, factoring completely means you can't take it apart. So 12t squared minus 10t plus 2 is divisible by 2 because there's a common factor of 2. So let's go this. This is 2 times something, that's 2 times something, that's also 2 times something. So this is, that's 2 times 6, that's 2 times 5, and that's 2 times 1. No big deals. We can still take things out of it. So we can pull that 2 out. So let's take the 2 out, and that's what we're left with. So we take out this 2, and what we're left with inside is 6t squared minus 5t plus 1. And we can't really take that apart anymore. So then what we would do is we would factor that madness. And we would go through and factor that. And we do that the same exact way as before. We set up our box, move this over a little bit, get our diamond going. Okay, maybe a little larger diamond, just because I tend to write kind of big. Okay, and so we have our first, our 2 terms that are leading are going to go here. Okay, and then the middle term is going to go here, And they still exist. Okay, that's our middle term that we're working about. We're not worried about the 2. We're only doing the part that's in blue. So this is what we're factoring, the blue part. So let's just take this then, and we got our 2 yellow terms here and here. And so now we just factor these, and we got 6t squared, and we got a positive 1. 6 times 1 is 6. So that's 6t squared. And then we got negative 5t here, negative 5t. And what's going to multiply to negative 5 and also, or add a negative 5 and multiply to positive 6 if they're both negative, 3t and 2t. Negative 3 and negative 2 is negative 5. Negative 3 times negative 2 is positive 6. And the whole key to this is remembering we're not done when we think we're done. All right, so let's look at getting those blue pieces factored. And then I'm going to factor them in red here. So let's see, we need to have a t and a t. We got to get a negative 3, so that'd be 3, that'd be negative 1. And then we got to get a negative 2 over, okay, so we need to get 2t times 3t is 6t squared. 2t times a negative 1 will give us a negative 2t. Negative 1 times negative 1 is positive 1. And now we have it. So what does this become? I'm going to do these in a slightly different color so we can actually see where they go. I will put these into orange. Let's do that. It's kind of like red, but it's a piece of it. All right. So there we go. So now what we have to completely factor this is we still have that 2. Okay, we still have the 2 times the 2 pieces that we have over here. So we now have 2t minus 1 and 3t minus 1. And when we multiply all that out, we will end up getting 12t squared minus 10t plus 2. As long as we multiply this whole box times 2. So that's where that's the one thing that you got to remember is you're not done when you think you're done. So we took that 2, put it here. We took the 2, the red 2, and then the orange pieces. Let's make these something else. There we go. Now we can see a little better where they came from. So we took the pieces apart, and factored the blue, then we get the gray, and so that's the important piece that we need to remember with this is that it all has to come together at the end. So that's completely factored. So now we have the same one. Nope, we got a different problem. So now we're going to rewrite this with a common factor factored out, just like we did before. And if you look at this, we can go 10, 25, and 15. That's each with 5s. Okay, so what we're going to do is we're going to take this over this direction, and we're going to do it that way, and then bring it down underneath. And so that just becomes 5 times 2, 5 times 5, and 5 times 3. So what that ends up giving us, if we pull the 5 out, you pull out that 5, we're going to get the purple, which is going to be 2x squared plus 5x minus 3. And now what we're going to do is we're going to factor the purple. We are going to factor the purple. So this is the factoring of the purple right here. And so the pieces are still going into the same place. Those two are still going to be where they go, which is 2x squared and a minus 3, which becomes a negative 6x squared. And then we have this middle term, which very simply just goes right here, okay, which is 5x. And if we're going to look at what makes that, again, that would be, they add to 5 and multiply to negative 6. Let's see. Adds to 5 and multiplies to 6. How about 6x and a negative x? So 6x minus x is 5x, and 6x times a negative, 6 times a negative 1. Make this even more clear. There we go. Okay, and so now we just go 6x and a minus 1x. All right, and now we're going to again get our alternate terms here. And so we know we have to have an x with an x, and we got to get a 1, so the 2 is going to go here. This is going to be a 3. That's going to have to be positive, and this would be a negative 1, and there we go. So we now have these pieces factored for the purple. So let's take the 5 and the blue parentheses. So we went down here with the purple part. That's purple. Okay, so we factored the purple. Okay, and now we're going to put everything back together over here in our opening colors, and we took out the 5, and in the purple we have, so we factored the purple, which is going to give us x plus 3 times 2x minus 1. And so these are actually this color, and there we go. And now that is completely factored. And that's what we wanted to get to. So you take the piece out, you factor what's inside, and you put all the pieces back together at the end. And that's completely factored. Piece of cake. So let's give this a shot. Let's see how many of these we have to do. Oh, we just got 4, not a problem. Piece of cake. All right, so out of this, we should be able to see that we can pull out a 5. So that's 5 times x squared plus 5 times 3 is 15 minus 5 times 4. So there we go. And we would factor that. And then this next one, we can pull out a 3, which is 3 times x squared minus 3 times 2 is 6. Ooh, we can actually pull out something more, because we can take an x out of this. So if we take an x out of this, we then get 3 times, that becomes x squared minus 2x minus 15. And then let's look at these. We can take a 2 out of this, so we then say 2 times, that is x squared minus 2 times 25 is 50. And then here, we see we can pull out a y. So if we take out the y, we get x squared minus 3x minus 10 by undoing that. All right, so now we're set. And so now all that comes down to it is just doing some of the little stuff, which is everything goes in the same place. We've got this, that goes here. And so that's the first. And so remember, we're just working with what's on the inside. So that's x squared, and that's a minus 4. And we'll put the 5 in later. That's going to come in down here. That's where we put the pieces in. And over here, we're going to put the pieces in here. And right now, we're working with the pieces. All right, so let's do this. All right, so we're just working with what's on the inside, okay, because the 5 is already taken out. And so right now we're just focused on what's in here. And that's what we're working with. That'll separate a little bit. Okay, and so what we have then is we've still got that middle term, which is right here, which is just going to go right in here. All right, so that's 3x here, and then we get x squared, so that's a negative 4x. And we have 4x minus 1x. That will give us 3x and negative 4. So we get 4x and a minus x like this. And we know we have to have an x and an x. And so, let me see if I can keep some colors going here. So we're factoring the parts in the red parentheses. So let's just take out, let's make it red when we pull it out. And so we get x times x, that's a minus 1. And then this would have to be a positive 4. So now we have x plus 4 and x minus 1. X times 4 is 4x, negative 1 times 4 is negative 4, x times negative 1, negative x times x squared. Good. So we have x plus 4 and x minus 1, and that's done. Completely factored. Okay, so now let's do the same thing over here. So there we go, and we are going to still have the same thing different day. This piece goes here, this piece goes here, and so we then have this yellow one right here is going to go right in there. Okay, and so we have x squared minus 15, which is negative 15x squared, and this is a minus 2x, and 3 and 5 get to 15. So we got positive 5, or negative 5, negative 5x, and a positive 3x. That would get us to negative 2, and negative 5 times 3 is negative 15. All right, and then we start factoring this, so we know we have to have the x and the x. And that's the x squared. To get the 3x, we know we have to have a positive 3. And to get the minus 5, we need to have a negative 5 times x. And negative 5 times 3 is negative 15. And so that's what we got. We got x minus 5 and x plus 3. Factored completely. So there we have it. Piece of cake. It's easier when you pull it out from the beginning. Okay, so now, once again, we're doing the same sort of thing. I'll do these in blue. Some people like blue more. Okay, and this is x squared minus 25, which is the difference of squares. Which, if we know before, that's just going to be x plus 5 times x minus 5, and all of that is then times 2. So let me just do this, keep the same pattern going. So we have our 2. So we can recognize the difference of squares as x minus 5 and x plus 5, or x plus 5 and x minus 5. Some people like the positive first. And that's what it's going to give us, because x times x is x squared, 5 times negative 5 is negative 25, and 5 times x is 5x, negative 5 times x is negative 5x. They end up canceling out. That's the difference of two squares, and this one is completely factored. So that's what that becomes. This one is not the difference of two squares, so this one we're going to have to do the full Monty on it. So let's just take these out in blue. Okay, and here we have this. And so we know then down below here we're going to have y times whatever we end up getting. And that's going to be the completely factored form of this. So all we got to do now is get the stuff into the rectangle and all that happy business. And that's going to go here. And then we're going to have the middle piece, which is right there, go in there. So let's put that there. So that's a negative 3x. And then we have x squared and a negative 10, which is a negative 10x. So multiply the negative 10x, and it comes out to negative 3. The difference, 5 and 2 are separated by 3. And if we have the 2 is positive and the 5 is negative, that's how we get there. So we go negative 5x, positive 2x. And then let's take these in blue. So we know we have to have an x times an x. X times a negative 5 is negative 5x. X times positive 2 is 2. So now, and positive 2 times negative 5 is negative 10. We're good to go. And we can also check it going across the other way. Negative 5 times 2. blah, blah, we're good. So that's just x minus 5 times x plus 2. And that one is completely factored. Yes, it takes some practice to get to it, but once you start seeing it, let me see here, I forgot to do this. These are our first and our last. So that's done. That's factoring completely. So good luck. See you online.